There was a little mistake in the previous code there for the Bresenham's algorithm, which I will go over just now, and in fact you can have a look and see if you can work it out for yourself. Now, if you see these marks under my eyes, it's not because I've been up all night working and coding. I've been to the swimming baths this morning and I've had my goggles on and they make these marks around my eyes, okay? So let's bring up the code here for the Bresenham's algorithm. Now, I will give you a kind of hint here. I go in and do a test here for the steepest, and I set up a little memory location. So if it's steep, the memory location goes to a value of 1. If it's not steep, the memory location remains a value of 0. So of course, it's okay if you draw one line, but what happens if you begin to draw another line, and then another line, and then another line? What's going to happen to the value here? Potentially it will still be set at a value of 1. So what we have to do whenever we enter our subroutines, we're going to have to initialize these values so that you're not carrying over values, potentially carrying over values from a previous run of the code. So obvious now that after you run it and it doesn't work. So what I had to do is really for all of the subroutines, we're going to have to set the values in those subroutines, okay, so that you're not going to along and grabbing a value from memory, and that value from memory could have been a value that's been set in a previous run of this particular subroutine. So really what we want to be able to do is for that steep test, we could go in at the top here and just set a value here. So we could put in data #0, steep test. So it would set the value of the memory location steep test to a value of 0. So every time it comes in, it sets it at 0, okay? So that's all we really need to do in this code. We could do that one thing, but then there's a more general issue here. Shouldn't we be very careful and ensure that we set all of the values of the subroutine to a value of 0? After all, the values in the subroutine or the variables are just memory locations. So those memory locations ideally have the value of 0. They most probably will have the value of 0. But what would happen if we, for some reason, didn't have that value of 0 and it was still sitting set from the previous use of that subroutine? Then we're going to potentially have gunk coming in at the beginning, okay? So we don't really want that. We want to set everything to 0. So I could go up at the top here and I could find all of the variables that we have set at the bottom here, and I could put in the data #0 and put it into those memory locations. But I did decide not to do that because I actually have a different command here. So the previous commands here for the directives were ds, which was define storage. And the define storage just sets aside a memory location, and that memory location is a variable. Now, it doesn't initialize that value, so it just sets aside a memory location or 2 memory locations or 100 memory locations, but there could be any value within those memory locations. So what I decided to do was a bit sneaky. I decided just to use the DC command. So the DC command is define constant. So it's really for not so much defining a variable, but defining a constant value. So a memory location that would just maintain that one value. But what I can do is I could just use that and I just use it and I define the constants, and all of the variables I'll just define as constants. and then I can put the value of 0 into it so I can initialize all of them. And that has the effect of, the DC command has the effect of automatically adding the line that we require, which is the data #0, so it'll add it into the top. Now it's a bit sneaky because I think in reality what I should be doing is using the ds command and then going in manually and adding in this reset at the top, okay? But I'm being a bit sneaky and saying, well, I'll just use the DC command and I'll use it rather than a constant. We can think about it as a variable, but the variable is going to have an initial condition set, okay? So that's what I've decided to do. And the reason why I'm just doing it like that, and it's a bit of a shorthand way of doing it, is because it's just going to be a subroutine. And the subroutine is going to be in the ROM. And by rights, you know, no one's really going to know how I've generated it. I could have generated it via the ds command or the DC command, you know, or directives. But you're never really going to know that, unless, of course, I tell you, which I am telling you now. So anyway, so that's it fixed. And you can see here that I've drawn out a star here. So this code was, I never wrote this code. This was given to me by Timothy Morgan, who has created an awful lot of code and helped me out quite a bit in the past. So he's got a little bit of code here that just draws the lines, okay? And this is the outcome here, which is a pretty little star. I'll zoom right in so you can have a look. So there we go. So everything's working fine, and the algorithm is loaded as a subroutine in the ROM, and that you can draw out multiple lines, and it loads in all the colours, and everything is working just fine. So if you're interested and this all looks good and you would like all of the details, you can go and get the course. I've left the links there to the course. I would love to just give everything away for nothing, as I have said before, but I don't make any money out of YouTube and I need to have some money to survive. If I don't, then I can't keep making the courses, and there won't be a Design a CPU 3 course. So if you do like it, head off to the website. You can get the course for £10, which is, it's a nominal sum. It's not too much, considering it's a course that's taken me 6-7 months to produce. Anyway, that's me rattling on. I'll get you on the next video. Goodbye.